In today's note, we are going to be moving away from right angle triangles and dealing with non-right angle triangles. So we can still use trig with non-right angle triangles, however, we have to use something different. And what we're going to learn today is the sine law. So an example of where trig could be used in the real world, or where you might see it, is in something called triangulation. So triangulation is a surveying method that measures the angles in a triangle formed by three survey control points. So if you look at this example over here with the mountain, you have a kind of three, you can pick 3 points, whether it's the top and then these two bottom ones down here. So you can use these 3 control points, and you don't have to be at those points. As long as you have something there that you use as a reference, you can measure the lengths, or you can measure the angles, and then you can calculate the other side lengths if. And I'll just show you a small video of an example of how you can actually use triangulation. So while we may not know the actual math yet, I just want you to pay attention to how we can use or find angles, and then see where you can or watch to see where you can see the triangles kind of start to form, and then hopefully later we can do some math, see where that might be applicable. So while they were just using triangulation to figure out a third point, you could see how those lines do start to form a triangle, although not a right angle triangle. But using the math that we're going to learn, we could start to find distances and other measures in an example like that. So what we're going to be looking at today is called the sine law. And the sine law can be used to solve non-right triangles. This means no 90 degrees. There's not going to be a right angle, 90 degrees. And you're going to need 3 pieces of information in a triangle, or in a given triangle, to calculate. I'm going to go through and label this triangle. I'm going to label all the points A, B, C, and these capital letters are going to refer to the angles. And then I'm going to use lowercase letters to refer to the complementary sides. In this case, we have lowercase a for side A, lowercase b for side B, lowercase c for side C. And you can see that the A's, the B's, C's, they are all across from one another. And that's important, remember. And the 3 pieces of information that you need come from these kind of pairs of angles and sides. And what we see is that we have angle and side pairs. And this is important because the 3 pieces of information that we need are based off of these pairs. So first, we need to have one full pair which is an angle and a side. So here we were given angle A and side A, or angle B, side B, angle C and side C. Either one doesn't matter. So we need to have a full pair, something like this in red, and then we need half a pair. And what we mean by that, what we mean by half a pair, is either an angle or a side. So we need to be given one of the other pieces for a pair. So whether we're given just the angle or just the side, it doesn't matter. So those are the three pieces of information we need. An angle and a side, and then either another angle or another side. I am just going to make a small little mark over here. Note that capitals, angles, lowercase, side. So again, just referring to see a label on a triangle, the lowercase usually refers to sides, capitals refer to angles. So I'm going to write down what our sine law formula is. And our sine law formula, sine A, again the angle, over little a, the side, sine B over little b, so the angle side, and then sine C over little c. And that is our sine law formula. Now, even though we have three ratios set up with two equal signs, which we don't normally see, you're not always going to use a third pair. You're only going to use two of these depending on what information is given to you. Don't worry about, well, I've never seen an equation with two equal signs in it. You're not going to be using two equal signs. This is just to show the relationship between all the pairs is. When you get to an actual question, you're not going to use. So we're going to look at two examples. First, we're going to look at using sine law to calculate a length. So the first thing we want to do is check to see if we have enough information. And we have to look for a full pair and a half pair. Right now, I can see I have a full pair because I have the angle and its side. I am and then another pair partially done because I can see the angle, but I'm missing the side little b. So this is what we refer to as having a full pair. I'll mark that off. So this one here, full, and this one here is half. So that's what we refer to when when I say a full pair and half a pair. Now that we have all this information, I can use my sine law to calculate my length. I'm going to write out my full sine law formula, and I'm going to show you what I mean by how we don't need to use. So this is the full formula for the sine law, but as you can see by this triangle over here, I don't have any information for this C pair. And because of that, I don't need to include it at all. And I'm going to you just want so I can get rid of that C pair. I am going to still need the A1 and the B1 because A is full and given to me, and B is part of the one I'm trying to solve. So what that means is now that I have my formula, I can fill in my information. So sine big A is the angle, so 60 divided by its side, which is 22. Sine B is 76 over little b, which is my unknown side, one that I'm looking for. The next step here is I'm going to cross multiply. Here, cross multiply. Because that's going to help me get rid of the fraction. So when I cross multiply, I get b times sine 60, right? Top times the bottom, and then the bottom times the top, so 22 times sine 76. Now what I want to do is get b by itself. However, I am multiplying b by sine 60. Remember that sine 60 is just a number, so what I can do is I can divide both sides by sine 60. The one side will cancel out, and I'm left with b equals 22 times sine 76 divided by sine. And now all I have to do is use my calculator to calculate this part. Depending on how comfortable you are with your calculator, I would recommend doing each part first or on its own. So for example, I mean this part first and then this part second, and then do your division. If you're comfortable with your calculator, you can do it all at once, but just to try to avoid any errors, and I recommend to do it separately. I am going to keep some decimal places. So I've simplified both of those parts, the 22 times sine 76, 21.3, then sine 60 is 0.6. I divide those two. 24 is side length. So that's how you use sine law to calculate length. The next example we're going to look at is using sine law to calculate an angle, and it's very similar except for the last couple steps. Everything else is very similar. So what we want to do again is check to see if you have a full pair and half a pair. In this case, we do have a full pair. I have again my A's, angle A and side A, and I have half a pair here with C. I have the side, I don't have the angle. That means that I can solve for that. I'm going to write out our full formula again. Sine A over little a, sine over little b, sine b over. You don't need to write all three out. I'm just doing this to show you how we break it down from that big formula with the two equal signs to just one. So similar to the last one, because I don't have any information for the b pair, I can just get rid of this. That's how we break it down so there's only one equal. So sine A over little a, sine C. A 70. So now I can fill in all my information. Side A is 19. C we don't know, so we're going to leave it as sine C divided by 11. After we fill in the information, same steps as the last one. First step was cross multiply, which is what we're going to do. I'll put a little note. We cross multiply. We get 11 times sine 70 equals 19 times sine. Here, we're still trying to do the same thing. We want to get sine C by itself or C by itself. Because it's being multiplied by 19, I'm going to divide the one side by 19, divide the other side by 19. Cancels out on one side. 11 sine 70 divided by 19 is equal to sine C. Now, we're close to getting C by itself, but I want to find, again, C by itself. I don't want to find sine C. So what we have to do here is similar to what we have to do anytime we find an angle, or we have to calculate an angle using. And what that is, we have to use the You may remember this from when we did it right angle trig, the same idea here. If I want to get rid of this sign or move it over, it becomes the inverse, sine -1. And it's going to be everything that's on the other side. 11 times sine 70 divided by 19, c left on the. Similar to what we've done before, I am going to simplify the top first, then the bottom. (10.37) divided by 19. C. I am still going to simplify this one more step. You don't need to show all this work. If you are comfortable doing this in 1 or 2 steps, and you don't need to break it down this far. So 10.37 divided by 19 equals 0.544. Again, remember, try to keep a few decimal places. You don't want to round it too soon or too short, and that way your angle may be off by a few. Then, once we do the inverse of sine, we should get roughly 33 degrees is that angle. So, you can see that when dealing with the sine law, it starts out basically the same. Remember, you're looking for that full pair and that half pair. Actually, I will indicate here we have half pair. Plug in your information, cross multiply. When you're finding the angle, remember your last step, you should be doing the inverse of your trig function, so it's the inverse of sine, and then you should be calculating for c. Finding a side length, you just have to do the cross multiply and then start solving. But again, the steps are going to be the same every time you have to use the sine law. Using it to find a side length, it's always going to be the steps. Same with you're trying to find an angle, steps. Key thing is just figuring out what your pairs are and where the information.